Morning, I am Vincent and I am the team leader for Group B, and our project is developing a secure cloud infrastructure. The team members are Siddharth, Jaimin, Harshpreet, Nikhil, Bushra, and Dinesh. Table of contents are from abstract all the way to conclusion. So for this project, we have decided to use AWS, and we were able to use some tools such as VPC, CloudWatch, GuardDuty, and Security Hub. Cloud platforms offer scalability and flexibility but introduce security challenges. So this project develops a robust security infrastructure on AWS. Okay, for the problem statement, there is this wrong impression that if you're using cloud technology, then everything is automated and everything is already secured. But that's not correct. There should be controls in place to make sure that our cloud computing instances are secured from both internal and external threats. So the three objectives are mitigate risks related to unauthorized access and misconfigurations, implement real-time threat detection mechanisms, and ensure compliance with security standards, which we see at the latter part of this video. The scope. So we have network isolation, which can be done using VPC, encryption, and threat monitoring. And the tools used would be VPC, IAM, and Security Hub. The limitations would be, of course, as we have mentioned a while ago, we will only use AWS and we won't use the other cloud computing vendors. And of course, there will be high operational costs for this one because, as we all know, cloud computing technologies use the payment scheme such as pay as you go or pay as you use. We have used both private and public subnets and implemented basic monitoring, and the compliance will be handled by AWS Security Hub. This is the simple network diagram that we have. So this is the internet, and then we have the Route 53 service from AWS. This is a DNS service. And then we have the web application firewall, which we will demonstrate later on. This is used to provide additional layer of security for web-based applications. And this is our public-facing internet websites. And then NATing, or network address translation, is done by AWS. We have a network firewall, which is composed of security groups and access control lists, wherein only ports, or there are specific ports which are allowed from resources coming from the internet. For example, HTTP, HTTPS, and SSH. And then on our internal network, it is composed of an internal web server, a jump server, and Active Directory. And S3 buckets are also there for storage and storage of logging. Okay, now we go to the demonstration part. So let me open a website or a web browser. let me show you the VPC instances that we have provisioned. So yeah. So it provides some sort of logical segmentation. So a separate IP range is used by the internal network, and the one which is used by the external website is using another range. Okay, for the AWS console login, we have implemented MFA to provide additional layer of security when logging in. So let me just show you that one. Need to put the username, and the password. And as you can see, an MFA code is being asked. So let me just check on that one. Yeah. Okay, there you go. So we have also used the concept of IAM, Identity and Access Management. It is used to manage AWS resources. And for this project, we have used this username. Okay, next we go back to the EC2 instances, and then we need to check the security settings. So we'll try to pick one instance. For example, this internet web server. So all we need to do would be to go to the security tab, and then this is the page where we can explicitly allow the required ports. For example, we can see ports 80, 443, and port 22 allowed coming from the inside. And this is just a test rule for checking the connectivity. Next, speaking of the internet website, we have provisioned this one, and we have used WordPress for setting up this simple website. It doesn't have a static public IP, and it dynamically changes from time to time whenever you reboot it. Okay. So now we need to demonstrate web application firewall, and one of the prerequisites for setting up web application firewall is the creation of CloudFront. So CloudFront works like a content delivery network. Correct me if I'm wrong, it works like Cloudflare, wherein it provides faster and reliable access to websites across the world. Let's say, for instance, if your website is hosted in Singapore and then a subscriber is from North America, that means that we can utilize CloudFront to make the transaction more efficient by putting up the cache servers in North America as well. So we need to go to CloudFront. It says Global Content Delivery Network. So click on this and then go to the security tab, and then we can see the web application firewall details. And then we can see the security trends. Doesn't show something worth noticing so far. So we can also adjust the date based on your preference. let's say for the past week, and then you'll be able to see the requests done. Right. So the basic features have been activated, such as the core protection, SQL protections, and rate limiting. Okay. So we haven't enabled bot protection for this one because we might incur additional charges. Okay, now we need to demonstrate the disks which are being used by EC2 instances and prove that these disks have been encrypted. So again, if we want, we can pick another instance, let's say the Intranet web server. Let's click on the instance ID and then go to the storage tab. Click on the volume ID, and then there you go. Encryption has been enabled. Next, we need to ensure that we have proper backing up of our EC2 instances or other data, because this is essential for disaster recovery programs. So why is this thing essential? Number one, if in case we're doing some change management or firmware upgrade activities and that was not successful, then we can use this AWS backup to revert the changes done and go back to the last known working configuration. Another important instance would be if there was a ransomware attack and then our infra was sabotaged. So if we have the proper backing up mechanism, then we can immediately restore the infra as soon as possible. Okay, so we need to click on backup plans. Click on this one. And then we have a backup rule which shows the frequency of the activity. For this, we have set it to weekly. And then we also have the EC2 resources, wherein we specifically define the instances which will need to be backed up. And to check the backup jobs history, as we can see here, everything was successful. No error logs whatsoever. And yeah, these are our instances. Okay. Next, we need to demonstrate CloudTrail. So this is the logging mechanism inside AWS. This works like a syslog. It's a tracker user activity and API usage. So this was the trail which was done. We can go to the event history just to check the things that recently happened. Okay, there you go. When we logged in, it was properly tracked. The MFA activity console login. And then just today we stopped some instances. And yeah, due to time constraints, I would like to demonstrate the termination of instances. But a while ago, I created some tests EC2 resources and then terminated them. And yeah, these were properly logged by CloudTrail. Alright. So this CloudTrail functionality works hand in hand with CloudWatch. So CloudWatch is almost similar to SolarWinds if you have worked with that tool before, wherein if there's some sort of high CPU utilization, it would be detected by CloudWatch. A while ago, before I started the video, I created some CPU spike utilization activity on one of the instances. So we can check all the alarms. Okay, today is the 10th of December. As you can see, that high CPU utilization event happened. Okay. So aside from monitoring, we can also use AWS SNS notification to send this critical events to our email or even SMS. So let me show you one sample. So when we did that stress test, it was detected by CloudWatch and an email was sent to my college email address. Yeah, this is the one. Alarm. All right. Next, another important component of our project would be guard duty. So this is like an intelligent threat detection. And there is no steep learning curve for this one. This is easy to understand. So we can drill down on any specific date that we want for any security related logs that happen. Low for the past 7 days. Yeah, still low. Low vulnerability. And for the past 30 days, it was able to detect one critical thing. So if you want to drill down further, just click on this one. It's potential credential compromise. Let's see what happened. If we drill down further, yeah. Well, I can confirm this is my home public internet IP, and this was done sometime 2nd of December while I was trying to do some CI/CD pipeline provisioning using GitLab. So nothing to be alarmed of this event. Yes. Okay. Now it's time to demonstrate the Active Directory users and computers. So this is our jump host. And then the only way to access the Active Directory is coming from this jump host. Okay. Click on this one. Now, this is my username. And I'm gonna type my password. Certificate was asked. Give it some time. Okay. And then let's check the Active Directory users and computers. Okay. And we have implemented some group policies such as the domain admins, wherein only 2 members were included in this group. So for testing purposes, let's try to log into this Active Directory using another username which is not a member of this domain admins and see how it goes. Okay. I'm gonna sign out. RDP. Can use another one. And connect. Okay, there's the error message. Alright, so that means our group policies are working fine. Okay, now we go to the next part, which is logging into the company website. So this is the page. Let me use my Active Directory credentials to log in. And there you go. So that's a proof that our AD or Active Directory login is working fine when we log into this WordPress website. Okay, now it's time to do some security posture checks on what we have done. So how to do that one? First of all, we need to go to the AWS Security Hub. How does this thing work? So it uses some frameworks in checking if we are in compliance. As you can see here, the benchmarks which were used were CIS AWS Foundations Benchmark, NIST, and AWS. Okay, this is a good marking because prior to using this security posture tool, our rating was around 21 or 29%. So let me just go back to the PDF diagram. Yeah, 29%. And after we have activated the security mechanisms, it went up to the green mark, which is 81%. And how does this thing, Security Hub, works? It works in tandem with AWS Config. So the AWS Config tool is like a baselining tool wherein it checks your configuration if it complies with the well-known security standards. Okay, and then we can also, what's this, integrate some secured CI/CD pipeline if we want to have a second opinion on the security posture of our website. Now for this exercise, we have used the DIST mechanism or built-in tool from GitLab. Okay, so far so good. Only medium and low findings were seen by this vulnerability assessment tool from GitLab. Now, what it does is that it scans the internet-facing web server that we have. So we can check on this thing, build, pipeline, and then go to the part or function where it says DIST. Just click on that one. And then it would show you the process that it did. So just a trivia, this DIST tool, which is built in GitLab, is using OWASP ZAP. Yeah, this is the public internet of our website. Okay, so we go back to the PDF presentation. We have seen the tools that we used, and the challenges would be the high costs, and of course the threat landscape is continuously evolving, so we need to keep up with that one and keep ourselves updated. In conclusion, we were able to deploy this project successfully by using the AWS tools. So as we can see, there was an improved security posture, compliance, and scalability. And in the near future, it would be better if we integrate it with other security tools such as AI, or maybe integrate it with security operations and automated response tools and other SIEM tools. That's it, and thank you for viewing. Once again, this is Vincent. Have a great day. See you. Bye-bye.